All right, today we're going to talk about polar coordinates. So polar coordinates is another way to graph items. Traditionally, we use an x and y coordinate plane, but in a polar coordinate, what we're going to be looking at is we're going to be looking at a radius and an angle. So any x, y coordinate that we put on a graph, we could actually graph in polar coordinates also, because what we're doing is moving it out so far from the origin up a certain angle. So when I'm graphing these here, so I put 1 in degrees, even though my graph is not in degrees here, I know that 60 degrees is pi thirds. So I'd come out to pi thirds, here's pi thirds. So I'm right along this line, and these are my radii, my radius measurements here. So 1, 2, 3. So there would be A, so 3 comma 60 degrees. So if I come here, B is, I'm at 3 pi halves. So I'm going to find 3 pi halves. Here's my 3 pi halves angle here. And I have a radius of 2. So I have 1, 2. Here is B. Now C is a little different because I have a negative radius here. So I'm going to go out to pi thirds again. Okay, so pi thirds is right along this line. But it says I have a negative 4 radius. So instead of going out 1, 2, 3, 4, what I'm going to do is I'm going to go backwards 4. 1, 2, 3, 4. And here's my C. So that's graphing polar coordinates. You're going to start with your angle and you're going to move out. So if you remember back when we were in a coordinate plane, we had our coordinate graph here. So we had an x and a y. We would find r. So here's our triangle that we created. And we found out that cosine of theta is equal to x over r, or x is equal to r cosine of theta. That's important when we start looking at polar coordinates. And then we did the same thing for sine. So sine of theta is y over r, or y equals r sine of theta. Well, like we did last time, we want to understand that tangent of theta is y over x. Remember, that helps us find that theta or that angle. So we're going to look at first here is we're going to look at converting. So we're going to convert from a rectangular coordinates to polar, and then here we have a polar coordinate that we're going to convert to rectangular. Okay? So the first thing I need to do is I need to find my r. Okay? So I want to find my r, I want to find my theta. So here I have 3, 3. So if I come back to my triangle here, here's a 3, here's a 3. I can find my r by using Pythagorean's theorem. So this becomes the square root of 3 squared plus 3 squared, which is the square root of 18, which is 3 root 2. Okay? So there's my first part of it. That's my r. So I know now that this is 3 square roots of 2. I now need to find my theta. And theta is equal to, if you remember last time, we talked about how theta was equal to tangent inverse of x over y. So now I have tangent inverse of 3 over 3, which is 1. So tangent inverse of 1. Well, if you look on your radian conversion chart, tangent inverse of 1, the first occurrence of that is at 45 degrees, or pi force. Okay? It doesn't necessarily matter which one you're in. It just matters that you put it in there. Okay? So this will be 3 square roots of 2, comma, pi force, or 3 square roots of 2, 45 degrees. Now in our second one here, we're going to do the same process. We're going to create our triangle. Let me clean this up a little bit. And so now we have two triangle here. So now our triangle is going to be down here because I have 2 square roots of 3 and negative 2. All right? So I need to find my r first. Okay? So I'm going to take 2 square roots of 3 squared plus negative 2 squared. This is going to give me 12 plus 4, which is the square root of 16, which is 4. Okay? It's good. Now I need to find my theta. So theta is equal to tangent inverse of y over x. So negative 2 over 2 square roots of 3, which gives me tangent inverse of negative 1 over root 3. Now you probably don't have that in your radian conversion table. You probably have it listed like this. Negative root 3 over 3. And you're going to want to find that in your radian conversion chart. And so when I find that, this becomes 330 degrees. And so now my polar coordinate is going to be 4, 330 degrees. And so there's my polar coordinate. Okay? So that kind of shows you how to convert from rectangular coordinates to polar. But now what happens if I have a polar coordinate and I want to convert it into a rectangular coordinate? Well, we want to go back to this idea here of x and y. So x equals r cosine of theta and y equals r sine of theta. So I'm going to come here, I'm going to go x equals 10 cosine of pi thirds. I'm going to go y equals 10 sine of pi thirds. Hopefully you have your radian conversion chart. Cosine of pi thirds is 1/2. So this gives me 5 here. And this gives me root 3 over 2, which gives me 5 square roots of 3. And so my rectangular coordinate now is 5, 5 square roots of 3. And so that allows me now to have that go from polar to rectangular. All right, so that's converting. We're going to look at some traditional rectangular functions and see what they would be in polar equations. So if we have just a regular circle here, so let's say I have a circle with a radius of 5. So this is a circle of radius 5. Now, one of the things you want to know is you always want to kind of go back to this x equals r cosine, y equals r sine, and kind of look at that in there, okay? So if I were to plug what x is, so x is r cosine, so this becomes r cosine theta, quantity squared, plus r sine theta, quantity squared, equals 25. Okay? Now, if I square this out, this becomes r squared cosine squared theta plus r squared sine squared theta equals 25. You notice that they have something in common here. They have an r squared. So we're going to factor out that r squared. So r squared times cosine squared theta plus sine squared theta equals 25. Well, remember I told you there's one really important Pythagorean identity we need to remember. Sine squared plus cosine squared or cosine squared plus sine squared equals 1. So this becomes r squared times 1 equals 25. I want it in terms of r, so I'm going to square root both sides. R equals 5. So here I have a rectangular equation of x squared plus y squared equals 25. But in polar coordinates, I just have r equals 5 because it tells me what my radius is. It tells me I have a radius of 5 and I have all points through all angles of radius 5. Okay? So what you're going to do is if you have a rectangular equation, what you're going to do is you're going to substitute in r cosine or r sine of theta for x and y. The last thing that we're going to kind of just look at real quick is we're going to look at graphing. All right? So we're going to look at graphing here real quick. It's not something that we're going to spend a lot of time on, but I'm just going to touch base with it so you know. All right? I have two of them. We're going to graph r equals 3 and we're going to graph r equals 5 sine theta. Okay? So when we come in here, the first one is we're going to graph is r equals 3. Well, that tells me it has a radius of 3. Okay? So I come out to a radius of 3. So I start in my center, radius of 3, 1, 2, 3. And all that's going to happen is I'm just going to travel along that circle of radius 3. Okay? That's not too bad. So if I have a radius, r equals a number, it's just a circle centered at the origin, and we're going to create that circle. Now what we're going to do is we're going to look at r 5 sine of theta. So the first thing I need to do is I'm going to plug in. So these are going to be kind of circular in nature. They're going to curve around. So I'm going to start by creating kind of a little table just so you can kind of see here. So I'm going to create a theta and an r here. So I'm going to have 0, I'm going to have pi 6, pi thirds, pi, maybe I should have went, yeah, we'll go pi halves, kind of go from there. So if I take 0 here, so when I plug 0 in for sine, sine of 0 is 0, 0 times 5 is 0. So when I have 0 degrees, I'm actually right there. Okay? So now I'm going to plug in pi 6. So sine of pi 6 is 1/2. So this becomes 5 times a half, or 5 halves, right? So here at pi 6, 1, 2, 5 halves is going to be right about there. All right? And now I'm going to look at pi thirds. Okay, so pi thirds, I plug in pi thirds, I get, this becomes 5 times the square root of 3 over 2, which is 5 square roots of 3 over 2. All right, so we want to kind of find out kind of approximately what that decimal is. So 2.5 times the square root of 3. So this is about 4.33. So I'm going to have to kind of guesstimate 1, 2, 3, 4, probably about there. Okay? Now, if I put in pi halves, I get sine is 1. So this becomes 5 times 1, which is 5. 1, 2, 3, 4, 5. Here it is. And so what's going to happen is I'm going to continue to do that all the way through each of these. And so what happens is if I put in 2 pi thirds, I'm going to end up getting this graph, and it's going to kind of end up looking like this. And it's going to kind of come back in on itself. I know that's a real quick discussion about graphing. I just wanted to kind of show you graphing so you could have a reference for it. A lot of times we'll use programs to graph these or graphing calculators.